Hello, welcome to the next video in series of JNDI tutorials at jEdu channel. This episode will slightly differ from previous ones. This is because we won't focus on API of JNDI. Instead, we will discuss syntax of search filter expressions and look what queries and criteria you can create with them. I read that some of you have difficulties in code readability in my videos, and the reason is that I'm recording all videos in Full HD resolution. Therefore, from this video I will record it with the same resolution but with bigger font. Before continuing, please download two files linked in the description. First of them, jEdu search schema.ldif, containing one class with few attributes for presenting features of search syntax. Second, contains actual data that will be searched. After downloading them, do as follows. First, add a schema to your LDAP server. To do it, right-click Organizational Unit Schema entry and select Import LDIF file. Then choose jEdu search schema LDIF file and click Finish. Wait for your data to load and then create a new partition called jEdu search syntax and do another import. In this case, import LDIF file to root entry of jEdu search syntax partition and select search syntax data.ldif file. And that's all about preparing environment for this video. We will start with looking at syntax of the most simple atomic element of a filter. Such element consists of three things: attribute name, operator, and attribute value. We will also limit such expressions with brackets because this is what specifies RFC document. Every filter expression, even the simplest one, should be placed inside parentheses. Nevertheless, JNDI and LDAP allows you to write such simple expressions without brackets. We have four operators that may be placed in this pattern. First of them is equal. This operator results in that an object fulfills the criteria if and only if it has attribute with specified name and this attribute has specified value. It doesn't have to be the only value. Besides this one, there may be also others. They do not matter in such case. What's important here is the equality rule. The way in which attributes values are considered equal or not depends on the underlying directory system. In case of LDAP, each attribute has three properties that specify how this attribute should be handled when checking for equality or order. Such property is something called matching rule and simply specify what does it mean that attributes are, for example, equal. You can see which matching rules are defined for attribute in Apache Directory Studio in a schema browser. You simply right-click an attribute you're interested in and select Open Schema Browser, followed by attribute type description. There are three popular equal matching rules we will use in our schema. First is case ignore match that compares two strings and ignores letter cases. It is used, for example, in case ignore string attribute. Second, case exact match also checks case of letters. An example of it is case sensitive string attribute. The third matching rule for equality is integer match that compares two integer values. Let's now check how it works on the example. We will work with jEdu search syntax partition, so we specify it in the provider URL property. We create default search controls that we will use. And what we will search is an object with attribute case ignore string equal to doc. To print search results, we use a method that we have written previously. Now run the example and see that two objects match our criteria. Now change search attribute value to uppercase doc, for example like this. And now run example again. Also here, the same two entries have been returned. This is because this attribute has case ignore match rule for checking if attributes values are equal. To the contrast, there is another attribute in this schema and the same class with another matching rule. Let's search for the same value but in another attribute, case sensitive string. First we will search it with lower cases. As you see, now one object has been found. If you now change it to uppercases, again one entry is found, but a different one. This is because this attribute's matching rule for equal comparisons is case exact match. The last matching rule we will look at is used in integer fields. We have an attribute inside our jEdu search object class named integer, with alias int. There are two objects in the partition that have this attribute, number 252 and number 92. Let's find an object with integer attribute equal to 92. This represents such filter expression. Run the example. One object has been matched. Now change expected value to something like this. From mathematical point of view, this is still the same number, and the same is from LDAP's point of view. When you run this example, it also finds number 92 entry. This is because matching rule for this attribute is integer match. On the other hand, if you check attribute with string matching rule, it wouldn't work the same. For example, searching an object with case ignore string equal to 252 results in one entry. But changing expected value to a number with leading 0 produces no results. This is because those values were now compared as strings. There are plenty of matching rules used in LDAP, and description how they work you can find in RFC document with number 4517. It is provided in the URL in the description under this video. Now we go to the second operator representing approximation. It's tilde equal. It means what you could expect from tilde character. The value of attribute does not have to be equal, but must be approximately equal to a given value. The problem is that being approximately equal is not described by any RFC document or any other standard. It is up to the LDAP server, or in general a directory system, to decide when values are enough similar to say that they are approximately equal. From what I've been able to look in the internet, the most popular algorithm used here is sounds like. In such case, two values are considered approximately equal if they sound the same. Still, this is very objective and not specified by any technical rules. From that reason, this operator is very rarely used in both LDAP and JNDI. The next two operators are related to each other and allow you to work with ordered values. Those are greater or equal than and less or equal than. Also here, matching rules come to action. What is really used as a criteria to order attribute values are matching rules specified as ordering match property, and as always you may check it in Apache Directory Studio. For example, string attribute in our class have case exact ordering match or case ignore ordering match. Going now to our example, we want to find all entries where case ignore string attribute has value less or equal than uppercase jEdu. After running the example, you will see 7 entries matching our query. 2 entries with a number as value of case ignore string attribute, and 5 entries with string values. The order of ASCII characters is that all digits are before uppercase letters, which are before lowercase ones. You can check it by looking at their ASCII codes. Please note that even though values of 4 entries with lowercase values are lexicographically after jEdu uppercase value, they still match the query. This is because during comparing order of values in this attribute, we use case ignore ordering match. The behavior of second attribute, that is case sensitive, presents the following example. Now we will search by looking at case sensitive string attribute. If you now run it, you will see that only 3 objects match the search query. 2 with numbers as a value of search attribute, and 1 with uppercase docstring. Let's now look at integers and say that you want to search all entries with int value greater or equal than 100. This query will do the work. After running the example, you will see that one object was matched, and it is what we could expect. But let's see what would happen if you do this search by looking at case ignored string attribute, that for numbers also has a string with that number. First of all entries with string value under case ignored string attribute were matched. This is because of ASCII order of digits and letters. What's more, also entry with number 92 was matched. And this is not what we want. But the reason why it was matched is because in case of this attribute, case ignore string, it is checked for order as a string. And due to ASCII order, 100 is lexicographically less than 92. That's all about 4 simple operations for comparing attributes values. Now we will very briefly present one operator that we have already known in first video about searching. It is used when you want to check for existence of an attribute. Its value is not important. Also, it does not matter whether attribute has one or more values. For example, if you want to find all entries that have integer attribute specified, you use following query: integer followed by equal star operator. Here, no matching rule is used because there is no point in using any. Running this example produces output with 2 entries. Last but not least is substring matching. This is basically the same operator as equal to, but the difference is that on its right side you may use something similar to regular expression, but very simple though. The thing that allows to think about it as very simple regular expression is star character. In this case, this may be any number of characters. So for example, query that will find all entries with case ignore string attribute value starting with letter D will be D followed by star. That means that you don't care what is after D. This example, after running, produces 2 entries, because we are using attribute that uses case ignore substring match rule for substring operator. You can also find all entries that simply has O character anywhere in its name. The query looks like this. You want to have O, but what is before and after it does not matter, so you surround it with star. You can use any number of star characters you want to reach your goals. For example, query that will find all entries with name starting with letters S and T and ending with letter N, but also with letter R twice somewhere in the middle, looks like this. This query matches to 1 entry. You can verify it on your own that its name matches our expression. You can also use this matching for numbers and, for example, search for entries with integer attribute starting with digit 9. Maybe it's not too practical and I don't see any application of this feature, but who knows, maybe in some case you will need it. We have discussed the simplest atomic expressions so far. It wouldn't be too powerful if you could not join them in one bigger expression. Search syntax allows you to use 3 most basic logical operations: AND, OR, and NOT. The syntax of 2/3 of them is following: logical operator, that is ampersand for AND, or pipe for OR, and then any number of expressions. Each of them must be enclosed within parentheses. Whole logical expression must be also enclosed within parentheses. NOT operation is a little simpler because you can only use it for 1 expression. Syntax is exclamation mark and then expression. Also here both negated expression and whole NOT expression must be enclosed within parentheses. Each of expression within logical expression may also be another logical expression. You can compose them with all possible combinations. Let's see at the example. We'll look for entries that match one of possible criteria. First, it can be a group of unique names with managers in its common name, or it can also be a person with surname that is before D in alphabet. Notice that here we can't use less than operator because there is no such operator in search syntax. Instead, we must use negation of greater or equal than operator. We'll use search scope to subtree in this case. Run the example and verify the output on your own as an exercise. As another exercise, try to explain why an entry with common name equal to Samuel Clemens does not match the criteria even though it has Clemens value in surname attribute. You can do it in comments section under the video. The next thing we will look at are special characters used in search syntax. Those are opening and closing brackets, star and backslash. And let's say that you want to look for an entry with some attribute containing star character. You can't simply write a star in your query, because it will be understood as special character, meaning any number of any characters. You need to use mechanism of characters escaping to do it. This table presents what you must use for each of the special characters. First, you write backslash character. It means that what follows must be interpreted as a character you want to put in a query, not as a syntax character. Then you simply write hexadecimal ASCII code of the character. In case of a star, you write 2A. In case of other, you use correspondent ASCII values. Let's look at the example. To look for an entry that has case ignore string attribute with value containing star, you use such query. Note the double backslash in this string. You must use it because backslash character is also used to escape characters within Java string. So if you want an actual string to contain backslash, you must escape it. This encoded part is also surrounded with actual star characters. This is because the star character in attributes value can be in any place, in the beginning, in the middle, or in the end. Run the example and see that one entry has been found. Other characters like parentheses or backslash can be encoded in the same way according to the ASCII codes. You can train it on your own. Now it's time for the last thing we will go through in this video: variables in filter expressions. The idea here is very similar to string format method. It is useful when you don't want to specify directly in a query attributes values, but instead defer it to an array of arguments. Let's look at the example with very simple search. We again search for an entry with int attribute equal to some value, but we use following syntax. We say that value in this place will be taken from the arguments array and from index 0. We now need to pass it. Here comes additional attribute passed as an object array. In our case, it will contain one element, integer with value 92. At the end we pass search controls. Both idea and syntax is almost the same as in case of string format method in Java or any other programming language. Of course, in such simple example there is no need to use this version of search. But not only primitive types may be used in evaluating such query. What you can pass here depends on the directory system you are using and what data types it supports. In our case we use integer. The most popular type is of course string. To show you more power of this feature, we will now search by an attribute with value that we will specify as array of bytes. A good example would be here some files stored byte after byte in attributes value, like JPEG photo of another person. But its content is quite long, so instead we will use our string attribute. We will find an entry with case-sensitive string attribute equal to dog, but we will specify dog value as an array of 3 bytes that are DOG ASCII codes. We might do something like this. Run the example and see that one object has been found. Bytes that are storing dog as attributes value in LDAP entry match the array of bytes we passed through a filter expression and its arguments. In the same way, you could look for a whole JPEG file's content if only you had array of bytes representing it. So this is basically all we will discuss in this video. Let's sum up what we have covered. First, we discussed simple filter expressions with different operators. Then we have introduced substring matching with use of special star character. To compose such expressions in bigger ones, we have looked at logical operations. After that, we focused on working with special characters by escaping mechanism. Finally, we looked how you can pass arguments to your filter expression by object array representing filter arguments. This and previous video is whole knowledge about searching in JNDI. I really hope you enjoyed it. As some form of summarizing videos about search, I have a question for you to think about and try to explain. What will be returned by invoking such query on jEdu search syntax partition with data provided in attached LDIF file? Can you explain this result? I'm waiting for your answers in comments under the video. As always, I also advise you to subscribe to jEdu, and if you like the video, please vote it up. I really appreciate any form of feedback. Bye guys, stay tuned and see you in the next video.